Hello class, today we're going to talk about direct variation. The standard that we're looking at right now is we want to represent linear proportional situations with tables, graphs, and equations in the form of y equals kx. Now I told you in the last video that we would come back and we would talk about this y equals kx a little bit more. And that's what we're going to do in today's lesson. So let's dive right in. Suppose I gave you this square. How would you find its perimeter? Well, if you remember what perimeter is the distance around a shape. So since it's a square, we know that all sides would be the same. So if I knew that this side was 5, this side over here would be 5, and this side over here would be 5, and this side over here would be 5. And we would just add them all together, or take one of them and multiply it by 4. Now, what if we wanted to find its area? Well, for area, we know we take just two of the sides, the 5 and the 5, and we multiply it together. Perimeter is the distance around, area is the stuff on the inside. Well, what we're going to look at today is, what if I changed one of those measurements? How would that affect the perimeter or the area? Okay, so that's what I want us to think about today. So let's see if we can investigate this. Let's say we had that same square, so here's that same square, and I gave you a side length of 0. What would our perimeter be? Well, if this side was 0, well, 0 plus 0 plus 0 plus 0 is still 0. Okay. Well, what if I changed it? What if I changed it to 2? So now this side's 2, 2, 2, and 2. We would now take that 2, multiply it by 4, and I'd get 8. Okay. Well, what if I changed it to 4? Well, 4, 4, 4, and 4 would make 16. Well, what if I changed it to 6 instead? Well, if you'll notice that each time we're just taking this number and multiplying by 4 because there are 4 sides. So 6 times 4 would give me 24. So I have a couple questions to ask you based on the information we just developed in this T-chart. With side length as our x and perimeter as our y. Is this a proportional relationship? Well, we learned in yesterday, or the last video that we did, the last lesson, that in order for a T-chart to be proportional, it must meet two conditions. One, it must contain 0, 0, must contain the origin, and there must be a consistent pattern on both sides. So down this side I'm adding 8, down this side I'm adding 2. So yes, this is proportional. So if it is proportional, what is the constant of proportionality? Well, we talked yesterday that constant of proportionality, well, that's just the same thing as slope. Okay, so in order to find slope from a T-chart, we find the delta y, which is 8, delta x, which is 2, and we divide those. 8 divided by 2 is 4. So what is our constant of proportionality? 4, because it's nothing but the slope. So then I ask the question, what's the equation then that represents this T-chart? Y equals, well, if our slope is 4, then it's just 4x. So as the length of our side changed, our perimeter increased. Okay, so what we're looking at today is, what is this constant of proportionality and how does it fit in with what we call direct variation? Okay, so what we need to remember, and this is kind of a hard thing to think about, in all the equations that we've had so far, they've been in the form of y equals mx plus b, where our m represents our slope and our b represents our y-intercept. Well, in a proportional situation, we know our y-intercept is always going to be 0 because proportionality requires us to include the origin. So in a T-chart, it must have 0, 0. In a graph, it must go through the origin. Or in an equation, our y-intercept will be 0. So the only thing that we're going to have is a slope. When we talk about direct variation, our m changes to a kx, where k stands for the constant of proportionality, or the constant of variation. Now, it will only change to a k if the situation that we have is proportional in nature. Okay, if it is just a regular line, okay, then this m is then just a slope. Okay, so if we have a line that has a y-intercept of something other than 0, then we use this formula, y is equal to mx plus b, because this b will be something other than 0. But if our b is 0, our y-intercept is 0, then y equals kx represents This line is a proportional situation. Okay? And I know that's kind of tough to understand. And so hopefully as we progress through this lesson, it will become a little bit more clear. Well, each one of these represents a direct variation situation. So are there any similarities to direct variation and a proportional relationship? Well, we know that in a proportional relationship, it must be a line and it must pass through the origin. So this is a line and it passes through the origin. All of these are lines and they pass through the origin. This T-chart, it passes through the origin and there's a consistent pattern. Okay? This doesn't have the origin, but could we have the origin? Well, let's see if we can find it. Well, if we look at this pattern right here, we're adding 20 cents. Over here, we're adding 1. So if I go back to the previous value, which would be 0, and I subtract 20 cents, I find that I have the origin. So all proportional relationships are going to be direct variation in nature. Okay, that we will be able to find a constant of proportionality or a constant of variation. So then what is this direct variation thing? For direct variation, two variable quantities are related proportionally by a constant positive ratio. That ratio is called the constant of proportionality. So if I told you that this K is our constant of proportionality and this K equals 8, then 2K, if I double K, I'm going to double the 8, which is 16. If I triple the K, I'm going to get 24. So that is a direct proportional relationship. Now we also know that this right here in algebra, this is our proportionality formula or direct variation formula. And if I wanted to solve for the value of K, I would end up with K is equal to Y over X. Because to get K by itself, I got to divide both sides by X. Okay? So in essence, the graph of a direct variation equation is always linear. It's always going to be a line. And it always contains the point 0, 0. The variables X and Y either increase together or decrease together. So for direct variation, okay, as one increases, the other one must increase. Or as one decreases, the other one must decrease. It can't go in opposite directions. As one increases, one decreases. It doesn't work that way. It's going to go the same direction. Okay, so when we're looking for direct variation, we're looking for this constant of variation constant. This is our direct variation constant or constant of proportionality. So in these three equations right here, do we have a constant of variation? If so, what is it? Well, if we look at the formula, y is equal to kx, where this k represents the constant of variation, this value right here will be that number. So in this first instance, 3 is our constant of variation. It's our constant change. And the second one, -9 is. Well, what about just y is equal to x? Well, we know x does have a number in front of it. It's 1, and that becomes our constant of variation. And then the last one, it's 1/3. Okay, well, what about in some graphs? Could we find a constant of variation? Well, again, constant of variation just means what's the slope of the line that passes through the origin. It's all it amounts to. So in this one right here, if I'm looking for the constant of variation, I'm looking for the slope, which we know is going to be rise over run from two good points. So I find the first good point, we know it's going to be the origin in a direct variation situation. The next good point is right here. So that means it rises 30 and it runs, well, pay attention, not 1, but 10, because our scale is 10. So then our constant of variation, if we simplify that, we get 3. What about in this graph? Well, again, if it's a constant of variation, we know it's going to pass through the origin, and we look for two good points. There's our first good point. Here's our second good point. It rises 3. It runs, in this case, 2. So our constant of variation is 3/2. Now, when we look at direct variation, what I need you to think about is there's a phrase that we always use in order to recognize direct variation. And that's this right here. Okay, direct variation, we will see this phrase every single time. Y varies directly as X. So if you see that phrase in the question, it is a direct variation question. So we come back and we get our direct variation formula. Y equals Kx. And we're looking for the constant of proportionality because that's what K stands for. K is the constant of variation or the ratio of Y over X. Okay, just like with slope. We know slope is rise over run. which is y, delta y, divided by delta x. So let's see if we can actually do a couple of direct variation questions. So here we go. Here's our first one. Suppose y varies directly as x. Okay, so there's that phrase. Suppose y varies directly as x. So as x changes, so does y. Okay, and they change proportionally. So if y equals 3 when x equals 5, then find x when y is equal to 5. Now we're going to work this question two different ways. Okay, the first way is going to be the hard way. Okay, so here we go. I know this is a direct variation problem, so I'm going to get my direct variation formula. Y is equal to kx. And the first thing I need to do is find the constant of variation, or the constant of proportionality. I need to find this k. So what I'm going to do is I'm going to look at my problem, and I'm going to find an x and a y that I know. It says if y is 3 when x is 15. So I know that is a true statement. So I can take this y value, this 3, and plug it into the y spot. I'm looking for the constant of variation, or the constant of proportionality, which is the k. So I leave k there, times the x value. And now all I have to do is solve for k. So to get k by itself, I divide by 15 because I have a multiply by 15. And if I do that to one side, I must do that to the other. So we end up with k is equal to, and if you do 3 divided by 15, you find out that that's 0.2 or 1/5. So that's my constant of variation. That's my slope, in other words. Or later on, you're going to find out that that's our scale factor. Okay, so now I'm going to take my constant of variation formula again. Y is equal to kx. Now I know the value of k based on that first point, 3:15 or 15:3. So I'm going to now look for the one that I want to find. So if y is 3 when x is 15, then what is x when y is 5? So I'm going to take that 5, plug it in. We'll take the k that I now know is 0.2, and then I'm going to multiply by x because that's what I'm looking for. So now if I divide both sides by 0.2, I end up with x is equal to 25. Okay, so I want you to remember that. Now this way I told you is the hard way. Okay, so let's see if we can now look at it the easy way. So again, we've got suppose y varies directly as x. So there, that tells me that I'm using direct variation. And I know for constant of proportionality or constant of variation, I have to have y over x, because I know that's what k is equal to. K is equal to y over x. Now we've seen that before many times. Anytime we found slope, that's what we've been using. Okay, so now, since this says constant of proportionality, there's a key word in that, proportionality. And inside that word, there's a part that we already know how to do, a proportion. And in a proportion, what we do to solve that is we look for a ratio I know. This is the ratio I know. If y is 3 when x is 15. So I'm going to place the 3 and the 15 in this format. Okay, so I'm going to put 3 over 15 equals. Because a proportion is nothing but one ratio equal to another ratio. So this is the ratio I know, and in a proportion, I'm also going to have a ratio that I want to know. So then find x when y is 5. So I take the 5, I put it in the y spot, I put the x in the x spot, and now what I do to solve a proportion is I cross multiply and divide. So I take the x and the 3, cross multiply those, you get 3x equals 15 times 5, which is 75. Then I divide both sides by 3, and I still get x is equal to 25, which is exactly what I did working it the hard way. It's just this now is the easy way. Okay, so let's see if we can do one more of those, and then I'll have you do one by yourself. Okay, so here we go. Suppose y varies directly as x. Find x when y is 10, if x is negative 7 when x is, or when y is negative 7 when x is negative 14. Okay, so we know we're going to be writing things in the form of y over x. So I look for the ratio I know. When it says find x when y is 10, if y is negative 7 when x is negative 14. So there's the ratio I know. That's the x and y that are together that I know. So I'm going to take my negative 7, place it in the y spot, the negative 14 in the x spot, equals. And then what is the ratio that I want to know? Well, I know the y, and it goes on top, and I want to know the x. So now what we're going to do is cross multiply and divide. X times negative 7 is negative 7x. Negative 14 times 10 gives me negative 140. I divide both sides by negative 7. I end up with x is equal to 20. And that's all there is to solving direct variation questions. Because in a direct variation problem, everything's going to be proportional. So we set up a proportion to solve it. So let's see if you can do this top one on your own. Pause the video and answer the top question. Okay, let's see how you did. So this one I'm going to look for a ratio that I know. It says suppose y varies directly as x. If x is 15 when y is 12, there's my ratio. So that's 12 over 15, which is y over x, equals, okay, and then again, find x when y is 21, so 21 over x, and so now we cross multiply and divide. X times 12 gives me 12x, 15 times 21 gives me 315. We divide by 12. We find out that x is equal to, I believe it's 26.25. That's all there is, because yes, you can have a decimal as an answer. Now let's look at this one last one, and then we'll be through with this video. Okay, this last one asks a different question. It says, suppose y varies directly as x. If x is 24 when y is 8, then what's the constant of variation? We need to remember that the constant of variation is nothing but the k value. Okay, so this one we set up our problem with our direct variation equation. We plug in what we know and we solve for k. Well, I know my y is 8. I'm looking for k, and I know my x is 24. So how do I solve for k? I have a multiply by 24, so we do a divide by 24, and I do that on both sides. And we end up with k is equal to 8 over 24. Now, that's not simplified, so we have to simplify it, because when you divide that, you end up with a repeating decimal. You're not allowed to have that, so we simplify to 1/3. And that's how we do direct variation. All we're trying to do is find the constant of proportionality, and then use that constant of proportionality then to find a missing part, because everything is increased or decreased proportionally. Until next time.